Alright guys, today we're getting ready to start chapter 3, lesson 1, talking about constant rate of change. Some of this is already filled out because I had started this video and then I needed to stop it, but I think I can go ahead and explain it without having to write the stuff in again. So let's talk about this. This chart shows that Marcus is downloading songs from the internet, and it tells us the frequency of how he's downloading them. And what it says is that Marcus, in the time, which is X, for every 1 minute, because this goes up by ones, 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1, 3 to 4 is 1. So for every 1 minute, which I've written down here, he is downloading how many songs? Well, if I look at the change in this, I have from 0 to 2, which is 2 songs, 2 to 4, which is 2 songs, 4 to 6, which is 2 songs. So for every 1 minute, Marcus downloads 2 songs. That's what we can see from that chart. And then it asks us to graph it. I've already started the graph down here. Hopefully you remember that your X is your side to side, your Y is your up and down, and you always go side to side first before you go up and down. So this first one is a 0 for my X and a 0 for my Y, which means I'm going to go 0 left to right, and I'm going to go 0 up and down, which means my first dot is right here at 0. My next set of coordinates is a 1 for the X and a 2 for the Y, which means I'm going to go over 1 and up 2. So here I went over 1 and I went up 2. So there's my second point. The next coordinate says 2 for my X, 4 for my Y. So that means I'm going to go left or right 2. I'm going to go right because it's positive. So I'm going to right 2 and up 4, and I bet I put that dot in the wrong place. Let's look. There's 1, 2, 3, 4. I sure did. That dot should be right here. That's a mistake. That's when I got interrupted and had to stop filming. If I look at my next one, this X is a 3. This Y is a 6. So I'm going to go over 3. So 1, 2, 3. And I'm going to go up 6. So 1, 2, 3, 4, 5, 6. Here is my next dot, and my final one is at 4, 8. So I'm going to go over 4, and I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So here is my final dot. Okay? So that's what the graph of that looks like. If I were to connect all these, it doesn't say to do that, but if I were, I would have a straight line. Anytime I have a straight line, let's flip the page and look over here. Anytime I have a straight line, I have something called a linear relationship. Linear means straight line, okay? And what that means is that the X goes up at the same amount each time, and the Y goes up or down at the same amount each time, okay? And we want to look at this. You always put the change of Y over the change in X. So whatever my change is for Y, I'm always going to put that over my change in X. So on this one, my change in Y was it went up 2. So that was why 2 came on top right here. And my change in X, which is right here, was 1. So that's why the 1 went on the bottom. And anytime it changes the same amount, it's called a constant rate of change. Constant means it's the same every single time, which means that it's going to be a straight line, meaning that that relationship is going to be linear. So now let's look at this next one. We're going to go ahead and skip number 1, and we're going to go straight down here to this graph right here. And we want to say, we want to answer, are these linear? So our question here is, are these linear? Well, we have to figure that out. We have to put the change in Y over the change in X. And if it doesn't tell you which one's X and Y, the first column will be X and the second column will be Y. So here's my X's. My X's are time. My Y's are going to then be temperature in Fahrenheit. So now if I look at the change, well, 5 to 10, to get from 5 to 10, I have to add 5. To get from 10 to 15, I have to add 5. To get from 15 to 20, I have to add 5. So the X's look okay. I'm going up by 5 each time. So now let's look at the Y's. On the y's, I go from 95 to 90, which means that I went down by 5, or I minus 5, which is okay. I can add or subtract. It doesn't matter. And then I go from 90 to 86. Holy cow, that's not 5. That's only 4. And then I went from 86 to 82, which is a negative 4. If these are not all the same number, my relationship is not linear. And I can justify that because my y's do not change at a constant amount each time. So now let's look at our graph. Well, here's our graph. Again, you can do this very simply by connecting the dots. Does that make a straight line? The answer is yes, it does make a straight line. So B is linear because if I connected those dots, I would have a straight line. Let's look over here. This is saying exactly what I said on this page. A change in y over the change in x. This right here says that exact same thing. A proportional linear relationship is a change in y over the change in x. So now let's look down here. And it's talking about temperatures. It says use a table to determine if there is a proportional relationship between a temperature in degrees Fahrenheit and a temperature in degrees Celsius. Again, if it doesn't have them labeled x and y, the first one is going to be x and the second one is going to be y. So my x is my degrees Celsius, and it looks like I'm going up 5 each time, so that's why there's a 5 right here, because that's my change in x. This is my x value down here. My y values then are going to be the change in Fahrenheit, and it looks like I add 9 each time. So my change in y then is my 9, so 9/5. So is that a constant rate of change? Well, the answer is yes, because it changes the same. All of these numbers are the same, and all of these numbers are the same. So yes, that is a proportional linear relationship. Very last one. We're going to use this table, and we're going to decide whether or not it is a constant rate of change. And it says, use the table to determine if there's a proportional linear relationship. Well, we have to see if it changes the same amount each time. So let's look at our x and y. Again, it doesn't tell me which one is x and y, but we already know that the first one's going to be x and the second one's going to be y. So weight is x in pounds and mass in kilograms is y. And it wants to know, is this proportionally linear? Well, if I look at my change in x, from 20 to 40, that's a plus 20. From 40 to 60 is a plus 20. And from 60 to 80 is a plus 20. So my change in x, hopefully you remember it's y over x, my change in x is a positive 20. My change in y then, to go from 9 to 18, is a plus 9. To go from 18 to 27 is a plus 9. To go from 27 to 36 is a plus 9. So my y is a 9. So if I look at that, 9/20, does it change the same on each single x and y? And the answer is yes, it does. So it is it proportionally linear? Yes. And what is the constant rate of change? I'm gonna abbreviate that COS, constant rate of change. COS, no, that doesn't make any sense. Constant rate of change, CROC, is what we're gonna talk about. And that is 9/20, because it's the same. It changes, the y always changes by 9, the x always changes by 20. All right, if you guys have any questions over this, bring those tomorrow and we will talk about them in class. Have a great night. Bye.